Welcome viewers to this last episode on hydrogen, which is dealt in Unit 9 of your class 11th chemistry book part 2. In the last episode on hydrogen part 3, we discussed the important aspects of water. Here we will be discussing about two more important compounds of dihydrogen. These are hydrogen peroxide, that is H2O2, and heavy water called by the formula D2O, where deuterium is there in place of protium. Let us first study about hydrogen peroxide. It is a very important industrial chemical and is used in the treatment of domestic and industrial effluents. It can be prepared by the following methods. First method is acidification of barium peroxide followed by removal of excess water by evaporation under reduced pressure, and it has been shown by the chemical equation here. You can see that hydrogen peroxide has formed by barium peroxide. Second method is acidified sulfate solutions on electrolytic oxidation give hydrogen peroxide, and the equation, if you see here, acidified sulfate solutions on electrolytic oxidation gives H2O2, and the reaction is 2HSO4 minus in aqueous medium on electrolysis gives you HO3 SSO3H aqueous, and it is peroxo disulfate anion. And if you see that it is obtained by hydrolysis and is shown by the equation here, and we get here 2 HSO4 minus in aqueous medium plus 2 H plus aqueous plus H2O2. The detailed reaction is as follows: H2SO4, which is in equilibrium with H plus ions and HSO4 minus ions. So, these are the HSO4 minus ions here, further dissociate, and again this is an equilibrium reaction to give us H2S2O8, which is peroxo disulfuric acid plus 2 electrons at the anode. This peroxo disulfuric acid now further gets hydrolyzed to give us sulfuric acid and H2SO5, and this is H2SO5, which further on reaction with water molecule gives us H2SO4 and hydrogen peroxide, and at cathode the reaction happening is 2 H plus ions plus 2 electrons are giving us dihydrogen. This method is also used for the preparation of D2O2, that is parallel compound to hydrogen peroxide, where hydrogen has been replaced by deuterium, and the reaction is K2S2O8 plus D2O giving us 2 KdSO4 in aqueous medium plus D2O2 liquid. Industrial preparation of hydrogen peroxide by oxidation of 2 alkyl anthraquinols. You know that 2 ethyl anthraquinol on oxidation gets converted to the corresponding quinone, and we get hydrogen peroxide in this reaction, as is shown here by the chemical equation. Hydrogen peroxide formed here is 1% in concentration. It is extracted with water and concentrated to approximately 30% by mass by distillation under reduced pressure. Further concentration by careful distillation at low pressure leads to approximately 85% hydrogen peroxide, and the remaining water is then removed by freezing it, and the water gets frozen out and we get pure hydrogen peroxide. After understanding the preparation of hydrogen peroxide, let us know its physical properties and structure. So, we will first explain the physical properties of hydrogen peroxide. Hydrogen peroxide is an almost colorless liquid and its color is very pale blue. It is miscible with water in all proportions and it forms a hydrate with water, namely H2O2 dot H2O, we represent like that. And if we say that 30% solution of hydrogen peroxide, it is 100 volume. Why it is called 100 volume? That means 1 ml of this solution gives us 100 volume or 100 ml of dioxygen at STP. The commercially marketed sample is 10 volume. That means its concentration is 3%, that is 3% of H2O2 is there. If we say that 1 ml of H2O2, if we take that, then it will give us 10 volume of dioxygen. The other physical properties as shown in the table can be glanced at, and after seeing that the table, you can compare these properties with those of water. Let us now have a look at the structure of hydrogen peroxide molecule. It is a non-planar molecule. Its gas phase and solid phase structures show a change in the dihedral angle from 111.5 degree to 90.2 degree, and the structures, if you see, are shown here both for the gas phase and the solid phase. You can also see the change in the bond lengths in these structures. Hydrogen peroxide can act both as an oxidizing agent and as a reducing agent, and that too both in the acidic and alkaline media, as we are going to study in its chemical properties. As an oxidizing agent, it gets reduced but oxidizes the other component which is present in the reaction. Here we are showing the reactions as an oxidizing agent both in the acidic medium and in the basic medium. As a reducing agent, it will reduce the other component or the substance present in the reaction medium and will get oxidized to oxygen, and the reactions happening in the acidic medium and in the basic medium are shown here. You can see that oxygen is coming out on the right side in the products, which is formed by the oxidation of H2O2. Now, some important aspects about its storage. As an oxidizing agent, it oxidizes in acidic medium as well as in basic medium. For example, in acidic medium, it oxidizes lead sulphide to lead sulphate, and in the process it gets reduced to water. In the second reaction, as an example of acidic medium oxidation, it oxidizes iron 2 or Fe2 plus ions to Fe3 plus ions and gets reduced to water molecule. And if we consider the basic medium, the same oxidation of Fe2 plus ions to Fe3 plus ions on one hand yields 2 hydroxide ions in the products by the reduction of H2O2. Another example, in the basic medium where H2O2 acts as an oxidizing agent is that of Mn2 plus ions, where Mn2 plus ions get oxidized to Mn4 plus ions, and in this process we are getting again minus OH ions or the hydroxide ions from the reduction of hydrogen peroxide. Now, the reducing action of hydrogen peroxide, that is, it can act as a reducing agent again both in the acidic medium and in the basic medium. We will first consider its reducing action in the acidic medium, where in the equation shown here or the reaction shown here, you can see that it is now acting as a reducing agent and it reduces MnO4 minus anion to Mn2 plus ion. That means there is a change in the oxidation state of Mn7 plus to Mn2 plus in the reaction. In the second reaction, where H2O2 in acidic medium is acting as a reducing agent and it is reducing HOCl2 chloride minus ions, and we are getting oxygen in this process. In the basic medium, when it reduces iodine, in basic medium, iodine on reaction with hydrogen peroxide yields iodide ions, and here again we are getting oxygen as one of the products. Similarly, the reducing action of H2O2 on MnO4 minus ions is giving us MnO2, that is manganese dioxide, and oxygen plus water, and the medium is basic. So, minus OH ions are there. After understanding the chemical reactions of hydrogen peroxide, let us now see some important aspects about its storage. These aspects should be kept in mind and are as follows. On exposure to light, it slowly decomposes to water and oxygen. Therefore, it should be stored in dark, and since the decomposition is catalyzed by metal surfaces or traces of alkali which are present in the glass containers, so it is stored in wax lined or plastic vessels. Similarly, one more factor which is causing its decomposition is dust. Dust induces its explosive decomposition. Since storage has been taken care of, now it is a time to see its wide variety of uses. Hydrogen peroxide has a wide variety of uses, and hence it is industrially produced in large quantities, and it is used as a hair bleach, mild disinfectant, and as an antiseptic by the name perhydrol, as bleaching agent for textiles, paper, pulp, leather, oil and fats. Also in the manufacture of sodium perborate and percarbonate, which are used in high quality detergents. It is also used in the synthesis of hydroquinone, tartaric acid, food products and pharmaceuticals such as cephalosporin. Also, its very important application is there in the field of pollution control for treatment of domestic and industrial effluent, oxidation of cyanides and restoration of aerobic conditions to the sewage wastes. Let us study about another compound now which is related to water and is called heavy water, represented by D2O, because here it contains deuterium instead of protium present in the water. The important uses of deuterium are as a moderator in the nuclear reactions, you are aware of this, and it is also used in the exchange reaction to study the mechanism of chemical reactions. It is also used in the preparation of other deuterium compounds, as you can show in the reactions where calcium carbide on reaction with D2O gives you C2D2 as one of the compounds which is equivalent to ethylene, if you remember. Similar reactions to the case of compounds in which hydrogen is present instead of deuterium. Similar reaction is there when D2O reacts with sulfur trioxide to give you D2SO4. Had H2O been there, you would have got H2SO4, that was sulfuric acid, and this is a corresponding reaction with D2O. And if we compare again with aluminum carbide, here with the D2O, we are getting CD4, a compound corresponding to methane. So, these are some uses of deuterium oxide or the heavy water to get another deuterated compounds. These are similar reactions you must be familiar with from your other units which occur for water. Now, coming to the preparation of water, D2O can be prepared by exhaustive electrolysis of water and also as a byproduct in some fertilizer industries. After studying these two important compounds of hydrogen, that is hydrogen peroxide and D2O, let us now come back to dihydrogen. Again we discussed in episode 1 where we mentioned that it can be used as a fuel. Why? Because it releases a large amount of heat on combustion. When compared with other fuels such as LPG, methane, dihydrogen releases more energy, that is about 3 times more on combustion when compared on mass basis with these fuels. If you see the table here for comparison of different fuels and compare that per gram of the fuel on combustion and the energy released is maximum for dihydrogen. If you see the data given in the table, in second row you can see that dihydrogen in the gaseous state gives us per gram an amount of energy equivalent to 143 kilojoules, and in the liquid state it gives us energy equivalent to 142 kilojoules per gram, and if the similar comparison is done for LPG, it is only 50 kilojoule, and for methane gas it is only 53 kilojoule, and similarly for octane it is 47 kilojoule only. So, definitely hydrogen is a better fuel if we compare per gram of the energy released in kilojoules. Another advantage of using dihydrogen as a fuel is that it creates lesser pollutants than petrol. The only pollutants are oxides of nitrogen which originate from dinitrogen present along with the dihydrogen. These can be minimized by adding water to the cylinder to keep the temperature low, which avoids the reaction of dinitrogen with dioxygen to give the oxides. So, pollutants can be minimized in this way. The problems or the issues related to the use of dihydrogen as a fuel are the mass of the container required to keep the compressed dihydrogen, which is 30 times, roughly 30 times as heavy as compared to the container required for storing the petrol. And another issue is use of liquid hydrogen. If we want to store it, we have to cool it to 20 Kelvin temperature, and so the expensive insulated tanks of alloys such as NaNi5, Ti, TiH2, Mg, MgH2 are required for storing even the small quantities of dihydrogen. You must be aware of a term called hydrogen economy, which has been in very much vogue as an alternative for the storage and transportation related issues. We all include all such issues under the hydrogen economy, and you must be aware of that a pilot project was launched for using dihydrogen as a fuel in October 2005 in India, where the use of 5% dihydrogen mixed with CNG for 4-wheelers was planned. In fuel cells also dihydrogen is used for the generation of electric power. So, the future looks great with dihydrogen to meet the ever growing demands of the energy. And before we end this episode, let us just refresh what we have learnt in this program. We discussed about hydrogen peroxide and D2O, which are two compounds, and then we discussed the structure and physical properties and oxidation and reduction reactions of hydrogen peroxide. After that, we studied that hydrogen peroxide is a very important industrial chemical and is used for a variety of purposes such as bleaching agent, disinfectant, antiseptic, and in the synthesis of various other compounds. It is also useful in pollution control treatment. The use of dihydrogen as a fuel was discussed along with the issues related to its storage and transportation. Now, you can see the reference for a website where Government of India's policy for use of dihydrogen is given in detail for dihydrogen as a fuel. And you must be happy to know that India's first hydrogen powered bus was trial tested in collaboration with the Tata Motors, and this is a picture of that bus. And also India's first fuel cell car was just tested for its trial run in 2020 only, just 18th of October is the exact date. So, you can see that now the future is there for using dihydrogen as a fuel mixed with the other fuels which are conventionally used. There are some questions here for you to ponder over. You must have heard a word dihedral angle we have used in the context of structure of hydrogen peroxide. Just explore what is dihedral angle. What does it mean? Second question is explore more about the uses of heavy water. Where is heavy water used? Find out the current status of hydrogen fuel production wise in India. How does hydrogen peroxide act as a bleaching agent? Find out the cost of dihydrogen per kg and what are the issues related to storage and transportation of dihydrogen as a fuel. So, read more about hydrogen economy from different sources you have at your disposal. We hope that you enjoyed watching this episode. We thank you for being with us.